ask whether or not this extra example even showed up in your packet, or if this is something we had added after the fact. You guys have this in your packet? Okay. So maybe go back to the page that we just finished, and you know how there's those lines for you to write stuff off to the side? I saved this one because you guys were doing fabulous with this on Friday, but my worry was that over the weekend you might forget some stuff. Packet. It's okay, I've got spares.
Thank you.
All right, so go ahead and write this one down somewhere. No matter where, little lines on the side would be good places for me. If I would sit where you are right now. 4 plus 3 to the 2x minus 1 equals 75. Now the question is, do you remember what to do with this? Because this was Friday. What would you do first? Subtract 4. Absolutely. We have to subtract the 4 because we need this base all by itself. Looks like that. Friday's just been way too long ago. Like I said, it's the pressure that comes out. You gotta think of what's for me. Anybody remember what we should do next? Log base 3. Exactly. We have to get rid of this 3 by using logarithms. So this will be gone. All right. Now, what would we do? See, everyone's using the stare at it and hope it goes away method. It's not working. You remember the change of base formula from Friday? Log of what you're trying to evaluate divided by the logarithm of the base. So then this becomes a calculator problem, because what we're going to do is find this, and then we're going to add 1. And then we're going to have to divide the whole thing by 2. So we'll need log of 71 divided by log of 3, add 1, and divide by 2. And that reminds me some people probably need to borrow calculators. So punch her in. I always do it in steps. I don't like using all kinds of parentheses to group stuff together. So I would definitely do my log of 71, finish off the parentheses. Divide by the log of 3, finishing off the parentheses. Add 1, and then divide by 2. So 2.4400, because we go 4 decimal places with logarithms. All right. Now, that was actually just like maybe the hardest problem in your life. And nobody asked for that problem. So on Friday, you totally do this. And give it a weekend, and we're kind of looking at it like it's some kind of foreign language. You know, it doesn't look right. But what we're trying to do is expose the base. That's always what this is about. Because we now know, after Friday, that if we need to get rid of a base that's being raised to an unknown power, we're going to take logarithms. And we know that we can use that change of base formula on our calculator, and we can actually get the numbers. Before we found out about the change of base formula, the only logarithms we could find were logarithm base 10 and logarithm base e. Because those are the only two that are on here. And your calculator just says that. We're supposed to know that it's logarithm base 10. And here's the bad thing. natural logarithm is actually a lowercase l and a lowercase n, but on the calculator, people were thinking it said the word in. So when they made the calculators, they made this an uppercase L and N because they didn't want people to get messed up. So natural logarithm is actually logarithm base E. So now, what we're going to do today is take this a step further and say, all right, let's just start solving some of the stuff that in the past we had to use Blinky for. Don't want to use Blinky anymore. Let's see what we've got. It says wood is resource management. Wood is a sustainable, renewable, natural resource when you manage forests properly. Your lumber company, you have a lumber company. That's good to know. Your lumber company has 1,200,000 trees. You plan to harvest 7% of the trees each year. How many years will it take to harvest half of the trees? When you harvest, are you adding to the trees or are you subtracting? So we're going to have to go back to a little formula that we used when we needed decay or depreciation, because this is the formula that actually removes things. So let's see. It said you started with 1,200,000. What do we do for 7%? 0.07, 2 decimal places. And the question was, how many years is it going to take to harvest half of the trees? Well, what's half of 1,200,000? 600,000. All right. Well, so right now this is 600,000 equals 1,200,000. What's $1 minus 7 cents? 93 cents. We want to use logarithms for this. We don't want to use Blinky. So we have to expose this base right here so we can do logarithms. That means 1,200,000 has got to go. What do we do with it? You divide. This is multiplication over here. We want to get rid of it. We're going to divide it. 1, 2, 0, 0. Put enough zeros on there. Yep. Wait a minute. Isn't 600,000 divided by 1,200,000 1/2? Of course it is. That's what we needed. Now, it is a word problem, and it already has decimals anyway. So if you wanted to change 1/2 to 0.5, if maybe you just used your calculator for the whole thing, who cares? You know, it already came with decimals. How do we get rid of a base of 0.93? Ideas. How do we get rid of it? Well, it has to be a logarithm, and the bases have to match. This is going to have to be logarithm base 0.93. Remember, the calculator could not possibly care less if we are using decimals for bases. It just wants numbers. That's all it wants. It really does not care if they're decimals. So over here, these are going to drop right out. And we just have to figure out how to punch that in on our calculator. And that's going to be using the change of base formula. So this is the log of 0.5 over the log of 0.93. And that'll tell us about how many years it's going to be until half of those trees are harvested. So log of 0.5 parentheses divided by log of 0.93 parentheses. Looks like about 9.5 years. Like it says, if it's harvested properly, what's happening is they're planting trees while they're harvesting trees in another part of the forest. So 4 says, after how many years will you have harvested half of the trees if you harvest 5% instead of 7% yearly? Okay, well, it's still half the trees. So it's 600,000. Equals 1,200,000 but it's not 0.07 anymore. What is it? Instead of 0.07, we're going to use 0.05. So what's $1 minus 5 cents? 95 cents. What's the next step? You don't want to call on people because it's a Monday morning. I'm going to have to if nobody's answering. What's the next step? Dividing. Yeah, and we're still going to get our 1/2 or our 0.5. So now what? Log 0.95. Yep. So what should we punch in to get our answer? Yep. Let's see what that comes up. So now they're only going to take 5% instead of 7%. So it better be more than 9.5 years. Log 0.5 divided by log 0.95. About 13.5 years. Which makes sense because they went from 7% down to 5%. So what we just saw here is an exponential equation. If whether or not we have growth and they're talking about populations, or we have, in this case, this was decay because it's getting smaller, our formulas were very easy for that. That was y equals a times 1 plus r to the t, and y equals a times 1 minus r to the t. But the good news is we don't have to rely on Blinky anymore. Now, Blinky would be an excellent way to check this. You know, we could still put y sub 1, y sub 2, use Blinky, we get the exact same answer. But right now, what we're supposed to do is solve these algebraically, and that means we're going to use that change of base formula to solve. So now, what else? A logarithmic equation is an equation that's going to come to us with logarithms already in it. So a logarithmic equation is an equation that includes one or more logarithms with some kind of variable. It's not a nice logarithm that we can sail shell ourselves and say, oh, look, that says 3. This is something where the x isn't going to disappear. It's just not. So we have to figure out how to solve something that has logarithms in it. So this one says, solve a logarithmic equation. What is the solution of log, the quantity 4x minus 3 equals 2? Well, if we don't understand logarithms, what we're supposed to do is snail shell to solve. But there's no base. Or is there? What's the base for this? It's 10, exactly. We're going to put a little 10 in here. And then, like I said, we know that if we've got logarithms and we can't understand them, all we do is snail shell. So this will be 10 squared equals 4x minus 3. Oh my gosh, that's easy algebra there. 10 squared is 100. 10 times 10 is 100. We add 3 to both sides. Let's skip steps here. And we divide by 4. So look at how easy that was. All we had to do was know that when there's no base there, that's a 10. And then we just snail shell, and away we go. Now, the book doesn't call it snail shelling. When you read through all the stuff that the book has, they're never going to mention a snail shell. They call it exponentiating. But that's what we do when we snail shell. We're making this into a power statement. So it's just easier to think snail shell as you work your way through it. All right. How was that one? If I gave you one of those today and said, hey, this is going to count as test points, 4, 3, 2, 1, 0. How do you feel about solving a logarithmic equation just like that? All right, some are more confident than others, but the numbers are pretty good. So let's try this one. What do you think? What are you doing first? Because I already see you working on it. What's your base? It is 10. So now the next thing is, what do you do with 10 to the negative 1? Remember, negative powers are just flipping. That's what they do. So this is 10 over 1 right now. This is going to be 1/10. Or you can certainly do it on your calculator. 10 to the negative 1 will come out as 0.1. All right, then we subtract 3. And we think, okay, if I had to do this by hand, which you don't, grab a calculator for it. 3 tenths would be negative 30 tenths. So this will be negative 29 tenths equals negative 2x. And then because we already have a fraction, instead of dividing by negative 2, it would be easier to multiply by a negative 1/2. So over here we'll have 29 20ths. Now let me show you, because you wouldn't have to do any of those fractions by hand if you didn't want to. You could punch in 10 to the negative 1. You could even write it down as a decimal at this point. It wouldn't matter. Subtract 3. Divide by negative 2. Math number 1. There it is. So you wouldn't have to do any of that fraction stuff by hand if you didn't want to. Checkable? Absolutely. You could take this 29 20ths and put it up here. LOG, that's on your calculator. So you could punch it in. Log, parentheses, in fact, let me demonstrate that. LOG, 3 minus 2 times 29 20ths. You got it? Right answer. So snail shelling is what we want to do to solve these. So then it's got to get tougher, right? Because that's just how things go. What if there's 2 logarithms on a side? Well, we can't snail shell that. We have to make it 1 first. So we have to figure out, how can I take this part, the left side of this equation, and just make it say LOG one thing. Well, that's from condensing and expanding. This would be called condensing. We want this together. Addition in logarithm language came from what? Multiplication. So this would be the logarithm of, and I'm going to put x first, times x minus 3 equals 1. Well, we know how to multiply x through those parentheses. Let's distribute that. I'm going to keep my little parentheses around the whole thing there so that we know it's the logarithm of all of that. Now we have one logarithm. Now we can snail shell if we know the base. What's the base? It is 10. Yeah, LOG is base 10. So this is going to say 10 to the first equals x squared minus 3x. Oh. Okay, well I know 10 to the first is 10. All right. This is not linear. It's not x to the first. If it were x to the first, this would go super duper fast. But this isn't. This is x squared, which is quadratic. You have to think, how do you solve quadratics? What do you remember? We have to factor. So if we want to solve quadratics, solving means finding the zeros. So we're going to have to move that 10 over, and then we're going to have to factor and see if we can find some good answers. So subtract the 10. Looks like so. Now, there's not a perfect square monomial we can pull out of that. It's not a perfect square trinomial. I know that because negative 10 in the back is not a perfect square. But my hope is that we can find 2 numbers that multiply to negative 10 and add the negative -5 and +2. So what would our answers be? What's the answer to this one? 5. What's the answer to that one? -2. Now I'm a little suspicious of one of these answers. That's that -2. So what I would want to do is check and make sure that this is going to work. So 5 and -2. Let's see, if we put 5 in here, it's going to say LOG of 5 minus 3 is 2 plus LOG of 5 equals 1. And that I can just punch in my calculator and make sure it's going to work. So LOG 2 plus LOG, oops, forgot my parentheses, that would have been bad. LOG of 5. Cool, we got one, it works. So this one's good, but that wasn't the one I was worried about anyway. LOG, -2 minus 3 is -5. Wait a minute. Can you take 10 and raise it to a power and get -5? The negative's out. It doesn't work. Negatives are not going to work. And that's because all the bases we've worked with in this class have been positive. There's no way to raise something to a power and make it negative. It doesn't work that way. So let's take a peek at this one. Logarithm 6 minus logarithm 3x equals -2. Now we need one logarithm on the left-hand side. So what is subtraction in logarithm? Division. So this was log of 6 over 3x equals -2. Can we snapshot that? What's the base? Yeah, this book gives us lots of base 10s, which is kind of nice. So 10 to the -2 equals 6 over 3x. Now this one, I would definitely change back into a fraction, because it's going to be 1 over 10 squared, which is 1 over 100. Here's why. How do you solve something that looks like that? You cross multiply. That makes this problem make a lot more sense. So we'll have 1 times 3x, which is 3x, equals 6 times 100, which is 600. Divide it by 3. And there's our answer. Now that's a positive answer. It's going to work. It's just the negative answers that are not going to happen for us. Positive answers, we're just fine. Oh my gosh, we're done? So 43210, me on how you feel about the last two that we just did. Yeah, a little, I'm sure with the factoring, you're thinking, hey, I'm a little rusty with factoring here. So, and the condensing, everybody seemed a little bit rusty. So, let's see. We need this, but then we are going to take a formative quiz on Schoology. I know. How evil is that on a Monday, right? Oh, but you are rusty, so what this will do is it's going to remind you of the kind of stuff that we already did in 7.3 and 7.4. And it's, well, one of them is fill in the blank, I think, but the rest of them are multiple choice. So I will get those published while you write that down.